All right, so let's actually write binary search, public static void, int binary search. We are going to search int array for a target. Right, and let's go ahead and write our base cases first. Base case 1. The middle is the target. And well, actually, that's the second base case. The first one was if we're out of search space. How do we know that? Well, we actually have to put... Well, if we're searching not just an array, but a subsection of the array, we actually need 2 more variables. The start of the array, or start of the section that we're searching, and the end of the array. And this will be inclusive, right? We're going to start at this index and include the end. So here, for instance, when we start out our example, we are going to be searching, our start is going to be index 0, our end is going to be, well, this is index 4, 5, 6, 7, 8. So this would be 0 and 8. So what is our middle? So what is the middle of any range of these range, the index ranges? Well, we'll leave that for a second, so that's just something to hold on to, because we're still on our first base case. Can't jump the gun yet, right? So if the array is empty, well, how do I know if my subsection is empty? Well, we can use start and end for this. If start is equal to end, right, then that means we're just looking at one single item. That was the case in the last video when we were just looking for 105 and we got all the way to 101. The start and end were the same. But otherwise, the start is always going to be before end. And as we'll see as we write this, if they ever crisscross, if end is less than start, then something went horribly wrong because we couldn't find the item. So we'll return -1. And you'll see that how that happens in just a second. Okay? The other base case is we need to calculate what the middle index is. So back to that question. Int middle. How do I figure out what the middle index is? Well, we can figure that out, right? So let's see. The middle index of this was pretty easy to find out, right? There were 9 items. That was 0 through 8. So 8 divided by 2 gave us 4. Interesting. What about for this guy, though? Well, our start was over here. It was index 5. Index 5. Index 5. And index 8. Index 5, index 8, right? So how did I know to check index 6? Well, the way we figure out the middle of this range is that we can add these 2 items together, we'll get 13, and then divide by 2, which in the mad world of computer science gives us 6. So the middle, you might write, is start plus end divided by 2, and that makes total sense to you, but it is actually completely wrong, because why? Because your professor forgot to put parentheses around start plus end, right? If we do start plus end divided by 2, this will divide end by 2, and then add it to start. I think what we're asking for, the middle array is equal to start plus the end divided by 2. And you can pause the video and check that out for any kind of range. But that will give you the middle index. That's how we calculate the middle index. It takes no time at all to figure out what the middle index is. Okay, so with that being said, if array, let's see. So now we have to basically check, is the middle item our target? That's our other base case. If array middle is, let's see, if that's equal to our target, we return the index that we're currently at, which is middle. If it's not equal to it, then it means that it's either less than or greater than. So let's go ahead and check. If array index middle is less than, well, actually, let's go ahead and just reverse this for a second. If the target is less than the middle, right? The target is less than the middle, right? Because I don't want to have to flip any logic around. That means we'll want to search the left side of the array. So this is our recursive case. Otherwise, if it's not equal to, it's not less than, it's got to be greater than. Okay? So if it's less than the array, so let's say we're looking for the item 2 in this array over here, right? We compared it against 7, right? And we said it's less than. So what's the range we need to check? What's the recursive method call we need to do? Binary search. Well, obviously, we're going to still search the same array. We're also going to return this. So we're going to return the results of binary searching what? Well, obviously, the same array. We're also going to look for the same target, so that's easy. So what about this range? How does this range... So this range is from here to here. Okay. And our old range, the range that we're calling from, it's from here to here. So how does that compare? Well, the two ISI, well, obviously the first one was the one we're going to do right now. It's a lot smaller. But they started at the same location, so the start is also the same. All that changed is the ending location. And the ending location, right, it used to be here, but it's not anymore. It used to be here at 101. But now this ending location is going to be over here at 6. So how does that compare? Well, where is that, abstractly saying? Well, it's right next to the middle. Specifically, it's to the left of the middle. So new end is going to be middle minus 1. So other way around, array, we're going to still search for and we're going to search the same. So if our item is bigger, we're going to search the right half of the array. So we're going to search the same array for our target. And this time, our end is the same, right? The ending of our range is the same as the one that called us. But instead, what's changed is the start. And the start will be just simply the element that's the next element that's bigger than the middle element. And that is that. I mean, as you can see, right here. The only difference is that I'm going to make this comparable in just a second. The next thing we're going to do is that having the user have to, or whoever calls this, have to, put in the start and end. That's just one place where that's just a way for this to go horribly wrong. So I'm going to make this private, because I'm not going to trust whoever calls this. Instead, I'm going to do something common, which is I'm going to make a wrapper. A wrappered method. Basically, a method that will call that will start the recursive process for us. Public static int binary search. Right, so I'm going to overload the method. Int array int target. So we're going to search an array for our target, right? So the user doesn't need to provide any of that information for us, and we'll just simply do return binary search the array target, and we're going to start a search at our start is going to be index 0 because that's where everything should start, and then our ending location should be the array dot length minus 1, the last index. So we want to search all the indexes. Public static int binary search, public static int binary search. Just the only difference is the number of arguments. So this outer one, which is we'll call our recursive method for us. So that way the user doesn't accidentally do something weird. Okay. So does this work? Public static void main. Let's go ahead and write int array r is equal to, let's go ahead and say it's equal to a new integer array. How big should we make it? Let's make it 10,000 items. Right? For int I is equal to 0, I is less than, And let's go ahead and do the same number, right? R dot length. And we'll just simply, we'll do I++. So for every item in the array, what we'll do is say R of I is equal to twice the index. Just to show that this works. So now, binary search for, let's go ahead and binary search for 0 in this array. So we're going to search array for 0. So run it, and it finds 0 just fine. It'll also find 64 just fine. It'll say its index is at 32, twice its value. What about 10,000? Find it at 5,000. Pretty close in the center, right? If we search for an odd number, 1001, it's going to return -1. And the reason for that is eventually, once we get down to our last item, right, we're going to either subtract 1 from middle or add 1 to middle from one of the ends, and those ends will, if we are down to one item, start and end will be the same. And depending on our value, we'll either subtract 1 from middle, which will move our end over this way, or we'll add 1 to middle, which will move everything. We'll add 1 to middle, which means that we'll move start this way. So things will crisscross, and which is this case over here, where we'll return -1. So this works very, very well. So as our last thing we'll do, so this is binary search, right? Search the middle, left half. We'll take a look at the middle. If that's not it, we'll search the left half of the array, or we'll binary search the right half of the array if it's greater. Right. So we look at the middle item. We look at the left half if our target is less than the middle item. We look at the right half if it's greater than our item. Otherwise, well, if it was the item we were looking for, well, then we're done. Okay. Last thing is to make this work on anything. So what I'll do is I'll say E extends comparable E. Ooh, what the heck did I just do there? So first things first, it's telling me that I need to do extends over here. So what I'm doing over here is I'm making this generic target and start. So I'm just going to simply change these over here, and now change this. So first off, to recall that comparable just simply means that it's something that can be sorted, right? Anything that's comparable is something that can be sorted. So normally I would just put an E here. Now by putting a E extends comparable E, what I'm saying is that my method, it uses E's. Those E's are not some other class, but they're just a variable they're just a marker, a type. They're just a marker for some type, right? There's some other class. It might be ints one day, it might be doubles another day, it might be strings another day, right? Now, by saying extends comparable over here, I'll just go ahead and leave that off, the E off there. It's saying that basically that every E, I'm restricting what can be passed into here. I'm saying the only thing that can be passed into here, the only array of E's, are E's that happen to be comparable. So I'll only pass in arrays of ints, arrays of doubles, arrays of strings, but I won't and can't pass in an array of scanners. Now that last E that I did over here, comparable asks to what? And this just simply translated says, the generics here, the E's here, can be compared to other E's. In other words, they're things that compare to the same type as opposed to different types. Okay, so int middle start plus end divided by 2. So now what we'll do here is dot compare to, which I have access to because I know that all the e's, all the elements in the arrays, are comparables. So compare to target equal 0, right? And if you can't remember what the comparable is, then just pause here and look at this slide, right? As a review, I also have another video on comparables that was like 2 minutes long, much earlier in the semester. So if they're the same, then compare to will return 0. Okay? Otherwise, so now we will translate this dot compare to. If target dot compare to middle is less than 0, right? That means that target will come before the middle. And so now that will work on anything. And just to prove it, boom. Oops. Oh boy, what's going on here? Did I have an issue over here with binary search cannot be found in incompatible bounds? Oh, right, because E. Right, because I can't, because it's an array of primitives here, E can only be. Let's go ahead and fix this then. E. Forgot to make my wrapper class match, right? So now we'll get an error over here which says, hey, you cannot pass an array of integers because that's a primitive. Or you can't pass an array of ints. So I'm just going to simply deal with an array of integer, no problem. Make it 1. And so now this should be found at index 500. All right, that is binary search.